Dear students, welcome to my classroom. Today we are going to start a new chapter, and the chapter is coordinate geometry. Students, coordinate geometry is needed to offer a connection between algebra and geometry with the use of graphs of lines and curves. It is an essential branch of maths and usually assists us in locating points in a plane. Moreover, it also has many uses in the fields of trigonometry, calculus, and dimensional geometry, and more. In previous classes, we learned some points regarding to this coordinate geometry about how to plot the points in coordinate plane. And before going to start this chapter, let us do an activity regarding to the point we learned in previous classes. Students, here we have a chessboard and there is a knight on this board. I think all of you know that how knight moves on chessboard. Now, what is the position of knight on this chessboard? So, it is in the box F1. Okay, F horizontally F and in vertically 1. So, the position of the knight is F1. Okay, now the knight is moving on. Now, the position of this knight is G3. Okay, horizontally Z and vertically in the third row. So the position of the knight is G3. And again, it is moving into another box, and then the position is E4, isn't it? Horizontally is in E and vertically in fourth. So the position of the knight is E4. And now the position of knight is D6. Okay. But how can we determine the position of a point in a plane? So here we are looking a red dot. It is a point. So what is the position of this point? Can we say? No. But by dividing this plane into parts, we can determine the position of this point. So how can we divide the plane? So we divide the plane into 4 parts using 2 lines, and the horizontal line is called x-axis and the vertical line is called y-axis. And the common point of these two axes is called origin and is denoted by O. Here we are looking the origin, which is the intersection point of x and y axis. Now, the x-axis, which is on right side the origin, is called positive x-axis, and the x-axis on the left side of the origin is called negative x-axis. Similarly, y-axis above the origin is called positive y-axis, and below the origin is called negative y-axis. Now we can determine the position of the point we have taken. Now the distance from this point to y-axis is 4 units and from x-axis is 2 units. So this distance is equal to this length. So the distances from the point to coordinate axis are 4 and 2. So the position of this point, that is the address of this point, is 4, 2. Okay. So by dividing the plane into parts with coordinate axis, we can determine the position of any point like this. So take one more point here. Here one more point is there. And now this point is 6 units away from y-axis and 3 units away from x-axis. But it is right side on the right side of origin. So we take we on left side of the origin. So we take the coordinates as negative x and positive y. That is minus x and 3. So the coordinates of this point are minus 6 and 3. And similarly, here we have one more point, and the coordinates of this point are minus 5 comma minus 4. And the coordinates of this point are minus 3 and 3. And if a point lies on x-axis like this, so its coordinates are minus 3 comma 0. So distance from y coordinate or y-axis is minus 3, and as it is lies on x-axis, its y coordinate is 0. Similarly, we can say that the y coordinate of any point lies on x-axis is 0. And here we have one more point, and the coordinates of this point are 0 comma 2, because as it is lies on y-axis, the distance from y-axis to this point is 0, and distance from x-axis is 2 units. So the coordinates of this point are 0 comma 2. So in this way, the x coordinate of any point lies on y-axis is 0. Okay, and as the origin lies on both axes, its coordinates are 0 comma 0. Okay, students, this is the way of plotting the points in coordinate plane. Now, the first part, determined by these coordinate axes is known as Q1, and this part is called a quadrant, because these two lines are dividing the plane into 4 parts, 4 quadrants, and the plane determined by positive x-axis and positive y-axis is called first quadrant, and the plane determined by negative x-axis and positive y-axis is called second quadrant, which is denoted by Q2, and the plane determined by negative x-axis and negative y-axis is called third quadrant, and this one is fourth quadrant, which is determined by positive x-axis and negative y-axis. And the coordinates of any point in first quadrant are positive, and in second quadrant, first is negative and second one is positive. and third quadrant both are negative, and fourth quadrant first one is positive and second one is negative, like this. We can see examples in these points. Okay. Now, how to find the distance between 2 points in coordinate plane? Let us see. So here we have 2 points A 2 comma 0, B 6 comma 0. What is the length of the line segment joining these 2 points? Or what is the distance between these 2 points? So simply we can say the distance is 1, 2, 3, 4 units, isn't it? So now the length of AB is 4 units. And here we have 2 more points, C and D. The coordinates of C are 1 and minus 3, and D are 7 minus 3. So the length of line segment joining these 2 points is how much? 1, 2, 3, 4, 5, 6. Because as this line segment is parallel to x-axis, we can easily calculate the distance between these 2 points. The distance is 6. Like this, length of any segment lies on x-axis or parallel to x-axis is nothing but the difference of x coordinates, isn't it? Here 6 minus 2, 4. Here 7 minus 1, 6. So here we have the distance between the point C and D is 6 units. And take 2 points on y-axis. P is 0 comma minus 2 and Q is 0 comma minus 5. And the distance between these 2 points is 1, 2, 3, 3 units. PQ is 3 units. And there is a line segment RS which is parallel to y-axis. And the length of this line segment is 1, 2, 3, 4, 5 units. So here we can say that the length of any line segment lies on y-axis or parallel to y-axis is the difference of y coordinates in that 2 points. Okay. Now, what is the distance between B and C? Can we say directly? No. How to find the distance between these 2 points? Let us see to how to find the distance between 2 points in the coordinate plane. Let A x1 comma y1 and B x2 comma y2 be any 2 points in the coordinate plane, like this. Here A x1 y1, this is B x2 y2. Join these 2 points and let P and Q be the projections of A and B on x-axis. Now, OP, the distance from A to x-axis, is equal to its y coordinate. Is AP is y1 and OP is x1. OP is x1, AP is y1. And similarly, OQ is x2, BQ is y2. Okay. Now, draw a perpendicular from A to BQ and let C be the projection of A on BQ. Now, the distance AC is equal to PQ and the length of PQ is equal to OQ minus OP. But already we have OQ is equal to x2 and OP is equal to x1. So that AC is equal to x2 minus x1. Similarly, the length BC. BC is equal to BQ minus CQ, isn't it? Now, we have BQ is equal to Y2 and CQ is equal to AP, and AP is equal to Y1. So, BC is equal to Y2 minus Y1. Now, students, we can observe that here triangle ABC is a right angle triangle in which angle C equal to 90 degrees. Now, by Pythagoras theorem, we have square on hypotenuse is sum of the squares on remaining two sides. So that AB square is equal to AC square plus BC square. And we have AC is equal to x2 minus x1 and BC is equal to y2 minus y1. So we can write AB square is equal to x2 minus x1 whole square plus y2 minus y1 whole square. From this we can write AB is equal to under root x2 minus x1 whole square plus y2 minus y1 whole square. So the distance between the points A, x1, y1 and B, x2, y2 is under root x2 minus x1 whole square plus y2 minus y1 whole square. Using this formula, we can find the distance between any two points in coordinate plane. Here we can take as x1 minus x2 whole square plus y1 minus y2 whole square also. Okay, well, as there is square, we can take here x2 minus x1 or x1 minus x2. Similarly, here y1 minus y2 or y2 minus y1. So the distance between 2 points can be written as under root x1 minus x2 whole square plus y1 minus y2 whole square also. Okay, let us find the distance between a point to origin. So let O 0 comma 0 and B x comma y. Now the distance between these 2 points is using this formula we can write under root x minus 0 whole square plus y minus 0 whole square, which is equal to under root x square plus y square. So using this formula we can find easily the distance from a point to the origin. Okay, students, now let us start an exercise which is based on the formula of distance between 2 points in the coordinate plane. So exercise 7.1. Find the distance between the following pair of points. So first one is given that 2 comma 3 and 4 comma 1. So the distance between the points 2 comma 3 and 4 comma 1 is under root x2 minus x1 whole square plus y2 minus y1 whole square. This is the formula to find the distance between any 2 points in the coordinate plane. Now here we have x1 is 2, y1 is 3 and x2 is 4, y2 is equal to 1. Now substitute these values in this formula. So 4 minus 2 whole square plus 1 minus 3 whole square under root 4 minus 2 whole square plus 1 minus 3 whole square. And we know that 4 minus 2 is 2, 1 minus 3 is minus 2. So we get under root 2 square plus minus 2 whole square, and which is equal to root 4 plus 4 and root 8. And now we can write 8 as the product of 4 and 2, which is where 4 is a perfect square. So now we can split it into root 4 into root 2, where root 4 is 2. So the distance between the 2 points 2 comma 3 and 4 comma 1 is 2 root 2 units. Okay, so we find the distance between 2 points using the distance formula like this. So second one is minus 5 comma 7 and minus 1 comma 3. So the distance between the points minus 5 comma 7 and minus 1 comma 3 is, here we have formula under root x2 minus x1 whole square plus y2 minus y1 whole square. X1 is minus 5, y1 is 7, x2 is minus 1 and y2 is 3. So substituting values, we get minus 1 minus half minus 5 whole square plus 3 minus 7 whole square. And minus 1 minus half minus 5 is plus 5. So we get under root minus 1 plus 5 whole square, and plus 3 minus 7 is minus 4. Also we have minus 1 plus 5 is 4. So root 4 square plus minus 4 whole square, which is equal to root 16 plus 16 and is equal to root 32. And we can write 32 as 16 into 2, where 16 is a perfect square. So root 16 into root 2 and is equal to 4 root 2. So the distance between the given points is 4 root 2 units. Okay. Similarly, there is one more question. So I am presenting here. You just watch and observe carefully. So we get here root 50, and it can be written as root 25 into 2. So we can write directly 5 root 2. Okay. So the distance between minus 2 comma minus 3 and 3 comma 2 is 5 root 2 units. Okay. And one more question, a comma b and minus a comma minus b. So the distance between the points a comma b and minus a comma minus b is under root minus a whole square plus minus b whole square. So we get under root 4 into a square plus b square, so which is equal to 2 root a square plus b square. Okay. So next question is, find the distance between the points 0 comma 0 and 36 comma 15. So the distance between the points 0 comma 0 and 36 comma 15 is, directly we can write under root x square plus y square, where 36 is x and 15 is y. So root 36 square plus 15 square, which is equal to under root 1521. So let us find the square root of 1521. So take 1521. Now 3 is a 9, and subtracting from 15 we get 6. Now write down this part 21 and add 3 to this 3, which is equal to 6. And now 69 9s are 621. So here the square root of 1521 is 39. So root 1521 is 39. Okay. So students, that is the way to find the distance between 2 points in coordinate plane. That's all for today, and we continue this exercise in next class. See you. Bye.